Good morning, guys. So in today's video, I will be going over some separation techniques. You probably learned most of these in pre-AP last year, but we're just going to go a little more in depth this year over them and really focus on a couple of them. So the first one I'm going to talk about is evaporation. So evaporation is the process by which a solvent is boiled and therefore it's evaporated. So this would be when we have a solid dissolved in a liquid is when you would use evaporation. And basically, you'll boil off your liquid, and after your liquid is gone, you're left just with that solid collecting. So this would work for something like salt water, for example. So then there's our picture of what's going on. We have our solution of water and salt. It's heated till it starts to boil. Eventually, all the water boils off, and all that's left is our solid particles. Okay, our next one is distillation. And guys, I'm going to tell you guys, distillation is one of AP Chemistry College Board's favorite to ask about. So it's definitely important that you know what happens in distillation. So distillation we use to separate solutions of liquids. And basically, to be able to perform distillation, liquids have to have different boiling points. So they're separated based on the difference in their boiling points, and it's heated in a way such that only one of the liquid boils out, and then it basically travels through a condenser and it condenses into another beaker. So you're left with two separate liquids. Now, guys, something that's really important is to know which substance is going to boil out first. So the substance with the lower boiling point is going to boil first. But typically, we're going to want to relate that to IMFs. This is AP Chemistry. IMFs are huge here. So it's important to know the substance with the strongest IMFs is going to have the higher boiling point and therefore will remain in the original container, while the substance with the lower boiling point will condense into the receiving flask. So it is going to be really important that you not only understand that it's the lower boiling point that is in the new flask, but also that it has those lower IMFs. And be able to, if given two substances, determine which one is going to be in that flask, the first one to boil off. Okay, so that's distillation, just differences in boiling point. Okay, next we have chromatography. And in chromatography, it's separation of a mixture, and it can be a solution, a suspension, a vapor, and it's passing through a medium in which the components are going to move at different rates. So we say medium because it can be lots of different things, but the most common one is definitely paper chromatography. So paper chromatography has our solvent, and it travels up the paper, and it essentially drags the solution with it, and the distance it travels depends on differences in intermolecular forces. So basically, if we're talking about paper chromatography, the component with the weakest attraction to the paper is going to travel further than the components that have more attraction. So for example, if our paper was polar, our non-polar substances would travel farther than our polar substances would. So it's going to travel based on differences in polarity or just strength of attraction between the substances. So there are two types of the chromatography. The first one is thin layer chromatography. And that's kind of what you would think of as your traditional chromatography. So a sheet is coated with a thin layer of silica. A small amount of mixture is spotted at the bottom of the sheet. It's then placed in the solvent. That's our mobile phase. The solvent runs up that sheet, which is the stationary phase, by capillary action. Because the inks and dyes interact differently with the solvent and the paper, some will stay dissolved longer because they have lower attraction to the paper, and others will travel further up and then they'll travel up further. So if they have lower attraction to the paper, they will travel further up the paper. So there you go. You can kind of see right here, this is what it looks like. We have our ink mixture at the bottom of our thing. It's placed into the solvent. As the solvent travels up, it carries the ink mixture, whatever you're separating with it. It separates out over time because they have different attraction to the paper. So the stronger their attraction, or the stronger their attraction, the less to the paper, the less far they're going to travel. Where the weaker their attraction, the farther they're going to travel. And then the next one we have is column chromatography. And so this is a stationary phase of small particles of silica or just some other solid packed into a column. A mixture is placed on top of the column and the solvent is forced through. Different substances are going to come out at different times. So you would be able to collect them in different beakers. So like, for example, here we have a purple dye. It's going to separate out into red and blue. Red travels a little faster, so they're able to collect the red dye. Once they've collected all the red dye, move it and collect all the blue dye as well. So that's column chromatography. All right. Then we have filtration. Oh, and I should say, guys, chromatography is another one of College Board's favorites to ask about. So chromatography and dilution, I think, are really the two big ones that College Board asks about a lot and asks about almost every single year. So making sure that you understand what chromatography is and understanding that they travel different like lengths, I guess, based on their differences in attraction and their differences in intermolecular forces is going to be important for you guys to know. Okay, now let's talk about filtration. So when filtering a mixture, one runs through a porous barrier. Yes. Okay, let's try that again. Let me get the highlighter. Through a porous barrier, the liquid will pass through, but the solid will remain. So it's like sand and water. So we have our sand and our water. We have our filter paper. We put it in some type of funnel. The water passes through and the sand is left at the end of the day. And then our last one we're going to talk about in this video is nice and short and sweet, is a separating funnel. So a separating funnel is just a glass funnel with a stopcock or a tap. And we use this one for two liquids that are immiscible. And basically immiscible means that they don't mix together. And so one liquid will sit on top of the other liquid, essentially. So the liquid with the higher density will be at the bottom of the funnel, while the liquid with the lower density will be at the top. When we open our tap, the liquid with the higher density will start to flow through the funnel into a beaker. You close your tap once all of that liquid has traveled through, and then you reopen it and you can collect the liquid with the lower density after that. So here we go. We have oil and water. You pour it into the funnel with your beaker, and then the higher density liquid is at the bottom, lower density is at the top. You would open up your tap, let out that high density liquid. Once you've got all of that, you would close it and then move your beaker, put another one under there, and let out your lower density liquid as well. Okay, so those are our separation techniques that we're going to need to know. So the important ones, the really two big that you see on College Board over and over again, are distillation and chromatography, but the others are important as well. Okay, guys, as always, let us know if you have any questions. We will be happy to answer them. Have a good day.